Good morning everybody. Today I am going to say about sockets. Sockets are which allows communication between two different processes on the same or different machines. To be more precise, it is a way to talk to other computers using standard Unix file descriptors. In Unix, every I/O action is done by writing or reading a file descriptor. A file descriptor is just an integer associated with an open file. It can be a network connection or a text file or a terminal or something else. Next is where we'll use these sockets. A Unix socket is used in a client-server application framework. A server is a process that performs some function on request from a client. Most of the application level protocol like FTP, SMTP and POP3 make use of sockets to establish a connection between these client and servers to exchange of the data. These sockets are of four types. There are stream sockets, datagram sockets, raw sockets, sequenced packet sockets. The first two sockets are most commonly used sockets, stream sockets and datagram sockets. The last two are rarely used sockets, raw sockets and sequenced packet sockets. The first one is stream socket. The stream socket is delivery in which a networked environment is guaranteed. If you send through the stream socket three items A, B, C, they will arrive in the same order A, B, C. These sockets use TCP for TCP protocol for data transmission. If delivery is impossible, the sender will receive an error indicator. Next one is datagram socket. In this, the delivery in the networked environment is not guaranteed. They are connectionless because you don't need to have an open connection as a stream socket. It is dissimilar to the stream socket. You build a packet with a destination information and send it. This uses UDP protocol for data transmission. The raw sockets. These provide users to the underlying communication protocols. This also supports socket abstractions. These sockets are normally datagram oriented, though their extract characteristics are dependent on the interface provided by the protocol. The raw sockets are not intended for the general users. These sockets are very rarely used sockets. They have provided mainly for interested in developing a new communication protocols. They use for developing the very rarely used to develop these new developing communication protocols. Sequenced pocket sockets. The next one is sequenced packet sockets. They are similar to the stream socket with the exception that recorded boundaries are preserved. This type of socket is rarely used. This interface is provided only as a part of the network systems and is very important in the most serious NS applications. The sequenced packet sockets allow the user manipulate the packet protocol, that is sequence packet protocol or internet datagram protocol. The next one is socket system calls. The first system call is socket. Socket system call is used to create the socket. It contains domain, type, protocol as a parameter. The next one is set socket packet. This helps in maintaining options for the socket referred by the file descriptor. This is completely optional. This helps in reuse of the address and the port. And the next system call is bind. This is useful When after the creation of the socket, bind function binds the socket to the address and the port numbers. It puts the server socket in the passive mode, where it waits for the client to approach the server to make a connection. The listen system call takes the parameter of socket FD and backlog. The next system call is accept. It extracts the first connection request on the queue of the pending connection for the listening socket. Socket FD creates a new connected socket and returns a new file descriptor referring to that socket. And the next one is TCP client and server implementation. Here is the diagram which shows the client server implementation. If we are creating a connection between the client and server using TCP, then it has few functionalities like TCP is suited for applications that require high reliability and transmission time is relatively less critical. It is used by other protocols like HTTP, HTTPS, FTP, SMTP, and Telnet. TCP rearranges data packets in the order specified. This is absolute guarantee that data is definitely transferred from client to the server. TCP does flow control and requires 3 packets to set up a socket connection before any user data can be sent. TCP handles reliability and congestion control also. In UDP client-server implementation, the client does not form a connection with the server like in the TCP, and instead it just sends a datagram. Similarly, the server need not to accept a connection and just wait for the datagram to arrive, where server sends the datagram to the receiver. Datagram upon arrival contains the address of the sender which the server uses to send the data to the correct client. In this way, the client-server communication will be implemented. Thank you.